In this video, I'll talk about the systems development lifecycle. The systems development lifecycle is often referred to as the SDLC. It serves as a framework with multiple phases that is used to manage complex projects. Secured coding practices can also be followed when developing IT solutions, such as those published by OWASP, the Open Web Application Security Project, or recommendations from the SANS Institute, and also the Center for Internet Security, which provides system design recommendations and even benchmarks. Let's take a look at each phase of the system development lifecycle, beginning with project initiation, where the business need is clearly defined since our solution must address it. After which, we then take a look at risk assessments, we assemble a project team, and we think about the type of data that our solution will deal with, whether it be intellectual property, personally identifiable information, or some other kind of corporate data. We then must consider the stakeholders that will be involved, whether directly or indirectly, including software developers, network administrators, management, end users, which could also be customers, and of course, any third party involvement. Next, we must determine the functional requirements of the solution. So, based on the business need, what must it actually do? Is it going to be a mobile device application? Will the solution be used on premises or in the cloud or within a certain physical office space? Are there any legal or regulatory compliance issues that we have to adhere to? We also should consider whether the application needs to be highly available, for instance, if it's a mission critical application that the business depends on. And then at this point, we must define the security requirements, such as authentication, so the proving of one's identity, encryption of data at rest and data being transmitted, and we must also define any requirements to prevent data loss. So, in other words, the unintended leakage of data to unauthorized parties. Next, we actually get into the system design specifications, such as exactly how the security requirements will be met, as related to authentication, encryption, and data loss prevention. So at this point, we're starting to get into some detail related to security controls. Then we get into the development and implementation phase, where the solution, for example, might be built in the cloud, since these days public cloud providers offer platforms, databases, virtual machines that can be spun up very quickly to build and test a product, and then they can be essentially deprovisioned when no longer needed. So it's very quick to get this development environment. We're only paying for while we're using it, so it might make more sense to do that instead of building and developing a solution on premises. Part of development and implementation is also a peer review. So, to make sure that we've followed secure coding practices and so on. However, security, though, really needs to be considered through all SDLC phases, not just development and implementation. In the documentation phase, there are ongoing updates. There's continuous improvement where we're always assessing our solution to make sure it addresses business needs and that it also addresses any threats which are ongoing. They're always changing. We can also use documentation for training, for example, the onboarding process for new hires. Lessons learned can also be derived after incidents occur. So, really, documentation should apply to all phases of the SDLC. In the evaluation and testing portion, we should be doing things like enabling verbose logging to log all application components. We might even then capture network traffic to ensure that what's being transmitted is what we expect. We might stress test the solution to see how it behaves. Then we would submit abnormal data as input, and this is often called fuzz testing to see how the application reacts. We want to make sure that the application doesn't crash or reveal sensitive information as a result of the submission of abnormal data. And of course, we need end user acceptance for the solution. In the transitioning to production phase, we have pilot testing, careful observation of the results, and then we take a look at differences from our production versus our development environment. Despite our best intentions when testing, sometimes there are variables that just cannot be reproduced in a development or testing environment. So we have to really observe that in the production environment during the pilot testing. At the same time, usually what happens is we have to make changes to the documentation, whether it's best practices for our solution or even core documentation changes based on how it behaves in a production environment. As with everything, there's ongoing maintenance over time, even for the best of solutions, such as adding user accounts, perhaps making small functional changes as needed, and of course, patching problems that we discover over time. In the end, there is the eventual retirement of our solution. In this video, we discuss the system development lifecycle phases.